Well, so now you should see this Excel sheet, which is the RETScreen model. So let's proceed in the right way. So here in the RETScreen model you have possibility, well, of course, to name your project, to specify the location and other issues. Then the first point to see is clicking what kind of project are you going to analyze. Then on our RETScreen you have several possibilities. Simply power. You have also possibility to choose which kind of power. So in our case it's wind turbine. Okay, so we click on wind turbine. Also there is possibility to analyze isolated grid, off-grid or central grid. So we will remain focused on grid connected application. Analysis type, well, you have two levels. So first level, first approach, second level, more in depth. So we start with this. Heating value reference, well, this is only relative to heating or combined heat and power projects. So we can choose the language, the currency, so we use euros in this example. Then units, the metric units. For site reference conditions, we have a database. Then by clicking we can choose the country, so we choose United Kingdom, and well, particularly windy location in Scotland. So we have good wind speed there. Not so much radiation, solar irradiation, but there is a good wind speed. So we click OK. Then we have the possibility to see the data. So latitude, longitude, elevation, the wind speed with very good wind speeds. In January the average wind speed is 10, pretty high. And then for the rest of the months, and this is a measurement at 10 meters from the ground. So at this stage we have completed. Then we go into the energy model. Then we have three levels of analysis. So we have method 1, 2 and 3. We are now seeing the method 1. So for method 1 we should indicate what's the power capacity of this wind turbine. So we have chosen, well, let me show. We have a product database. Okay, so if we click on product database, we have a good library. So we have chosen Bergy wind power wind turbine. So here we can see the power curve data. Then we see how the cutting speed is about 5 meters per second. Then it starts providing 1 kilowatt. Then increasing up to roughly 15 meters per second. Between 13 and 15 meters per second it provides the maximum power, and then it decreases, but the cutoff speed is quite far. So we are sure that with high wind speeds this will produce, even if it's lower than optimal speed, between 13 and 15 meters per second. So we can choose several units, but we will choose one unit of 10 kilowatts. Then we click OK. Then coming back to our model, then we have automatically introduced what's the height of the hub. We have one unit, the height, the brand. So we have to introduce manually what will be the capacity factor. Well, in this method we don't have we have to figure out what will be this capacity factor based on average wind speed. In method 2 and 3 we will have the opportunity to introduce wind speeds per month, average wind speeds per month, and then having a more precise, a more accurate estimation of capacity factor. Capacity factor is roughly how many hours equivalent full load will run the wind turbine. So in this case, electricity exported to grid will be 26 megawatt hours per year. So here we choose what's the electricity export rate. In this case, we have chosen the average electricity price for United Kingdom for domestic users. So this wind turbine will avoid the expense of electricity. Base case system, this is emission analysis. So as for emission analysis, we have the possibility to compare what will be the avoided emissions. Then in this case we can choose what kind of fuel is alternative one. So if we choose coal, which is quite carbon intensive, we find a ratio of 0.8 tons CO2 per megawatt hour. If we add transmission and distribution losses, then we are close to 1 ton per megawatt hour. Well, this is probably one extreme assumption. We can choose other technologies like natural gas. In this case, we will be roughly at 0.4 tons per megawatt hour. So based on that assumption, we find 11 tons of CO2 as avoided greenhouse gas emission. It's equivalent to 2.2 cars on light trucks, but we can also choose other ratios like barrels of crude, which is 22, or hectares of forest absorbing carbon, 3.8. In the case we have an income because of greenhouse reduction, this is very interesting for countries not included in Annex 1 of Kyoto Protocol, which are eligible for clean development mechanism project. So in this case you could introduce here the market price for your carbon credits. We will choose 0. In this case we are in UK. Well, you could participate in the voluntary carbon emission market, which is much cheaper but growing. And then we go across financial analysis. So you introduce in this case your inflation rate, project life, so we choose in this case 15 years. Debt ratio, if you go to bank, well, not the best time now, but if you can have 80% finance at let's say 5.5 debt interest rate during 12 years. What's the initial cost? Well, small wind, it has comparable costs to photovoltaic system. So for 10 kilowatts we would be around 40,000 euros, 50,000 euros. So many countries are introducing incentives on investment for small wind systems. For instance, in Spain, you can have up to 3 euros per watt, which means in our case with 10 kilowatts you can have 30,000 euros for your project, which is a pretty good number. Then in this case, well, we have assumed a rate of subsidy of about 15-20,000 euros. Then in this case we have to invest 35,000 euros. Well, we do not introduce other incentives or grants. Assume 500 euros of operation and maintenance annual cost. Then based on this, and based on the prices we have indicated previously for the electricity production, we have this electricity export income, which is 4,000 euros annually, slightly more. Then in this case you can see here the cumulative cash flows graph, where you see how you have a payback time based on your equity of about 6 years, which is interesting investment. Well, it all depends on what's the amount of your investment. If you have to assume the full investment, let's say 45,000 euros, then in this case you start recovering your investment in almost 12 years. So it will be more on voluntary action if you don't have any other incentive. If we choose the method 2, then have to choose whether we are specifying wind speed. Then in this case we have the possibility to see maps. Then the next step is wind speed, the annual value. So we have this average for this location we have previously chosen. We have this average wind speed on annual basis. So you can type it manually. So in method 2 we specify an average annual wind speed, so 8.2 meters per second, measured at 10 meters high. So in this case we should also specify the average air temperature, the atmospheric pressure. Then we define, as we did previously, the power of our the nominal power of our wind turbine. We have chosen this model, 1 turbine, 10 kilowatts. The hub height is specified at 18.3 meters. So in this case we can benefit from a higher wind speed. So we have the area per turbine. Then RETScreen software provides with the expected generation for each wind speed. So these wind speeds come from the database for this particular location. So we have for 5 meters per second we have this generation, and then the best ratios are comprised between 13 and 15, because here we have the maximum output power. Then in this case, using this more accurate method, we find a capacity factor slightly higher than we previously used, so 39.9. Well, I can assure you this is an excellent location. Usually project let's say big wind, capacity factor is about 25% capacity factor. So the export electricity rate, we can either choose this price, which is let's say wholesale market price, but we decided to introduce 166, which is the household electricity price. Then in this case we see how with similar project ratio about finance, we can afford for a higher investment, 50,000 euros, because we have a much higher production. This is definitely, this changes definitely our financial figures and our economic figures for the project. Payback I can afford without the need of any subsidy. So in this case, with these high wind speeds for the north of UK, this, according to RETScreen analysis, we would be in economic rate for a small wind project.